few news articles you might like to see while we're waiting for the official start time. And what is this nonsense? There we are. Clubhouse. I have not been to Clubhouse. Clubhouse is the new social network, and I need another social network, like a hole in the head, which I think is a lot of people. But anyway, Clubhouse is the new hotness. Apparently, it's like a group phone call where a bunch of people can talk in voice, and it's considered very elite and cool to get an invitation to Clubhouse. But they point out that you have no control over it, and in particular, what it will do is try to connect to your Twitter contacts and your other contacts, and it will just spam all those people into your friends list, and there's no way to filter them out. So this is the same mistake Google made when they made one of their appallingly poorly conceived social networks, and they took everybody you'd been sending Gmail to and slammed them in as your friends. So people suddenly found out that everybody could open a timeline and see everything you're doing, including your crazed ex-boyfriend that's hunting you down, and your secret gay lovers, and your church group, and everybody was all slammed into the same group. And it looks like Clubhouse has done the same thing. They have failed to understand that people need some degree of privacy, and not everybody that they've ever had anything to do with is their friend. So it's a thing to know. Facebook is increasingly hated all over the world, increasingly blamed for a variety of bad things, and now what they want to do is force them to pay publishers when they link to their content. So Facebook has blocked news. Facebook is like people's number one source of news for a large number of people, and they have blocked sharing news links so they don't have to pay for the news content. Google has also been talking about leaving Australia because they don't want to pay for the news links, and Microsoft has said they will cheerfully enter and Bing will pay. And I think Google actually made some agreement to at least some of the news contents to pay. So it's, and this is, I think, a really big issue because local news has pretty much died out. And that's very bad for democracy, because the thing about democracy, they say, which I'm finally beginning in my old age to do correctly, is to look at the national news and then act locally. Because your vote doesn't mean much on the national stage, but your vote matters locally. So, but you can't do that unless you have a local newspaper that covers your local issues. And of course, in a place like San Francisco or New York City, we do have a local paper, but most cities no longer have a local paper at all. And getting Google to pay for the links would be one way to fund that. And that's what Australia is trying to do. And Facebook also. Lithuania buys luggage scanning equipment from China, and now they're blocking it. Just because they don't like China and they don't want to support the Chinese government because they're oppressing groups in China. They're sort of an anti-democratic force. And that's an interesting statement to take by Lithuania. We'll see if, in a way, America's been sort of toying with the same thing under Trump. We were having more and more angry embargoes and stuff on Chinese goods, although it wasn't very clearly connected to any exact statement of why we're mad at China. But I think Biden has suggested he is going to continue trying to be hard on China. And we'll see if it does any good. Various people have tried to shove China around, including Google, and most people have found that China doesn't care what you think, and they will bloody well do whatever they like, whether you like it or not. But it's possible that the United States has some influence. So I don't have an Apple M1. I don't know if any of you do, but it runs on ARM, and all software has to be recompiled for ARM to run, or it has to go through a translator. And now Patrick Wardle has found the first malware for M1 native. And there's some malware, which is a browser extension to pop up ads on the screen, and native to M1. So it's not too nasty, not too hard to remove, called GoSearch22, but it is an example of M1 native malware. There's a certain amount of Mac malware out there. The stuff I've seen have been like this. It's just been browser extensions and things that aren't too hard to find and remove. But there is some malware on Macs. And this one has been getting some attention. The Chinese make knockoffs of everything. There's fake watches. Cisco has said for years that I think 75% of Cisco repair calls are Cisco equipment being set in for being broken that is not real Cisco equipment. It's Chinese knockoffs. They make a box that looks like it, they put the Cisco label on it, and then they put inferior chips inside there and sell it. And if you go and buy discount computer equipment of any sort, like SD cards and memory for machines, a good part of what you get is Chinese knockoffs, inferior equipment, labeled, violating a brand. This is one of the many rotten things China does, and they also make bogus N95 masks. So DHS has seized some of them, and there have been many, many issues. This is one of the many trade agreements problems we have in China. They make a lot of counterfeit products. So a lot of people expected Joe Biden to cancel student debt, and he is not on board with that. He thinks $50,000 is too high, and you should only cancel a smaller amount of student debt because he doesn't want to bother canceling the debt to people that went to expensive colleges. So we'll see what happens of this. I don't know how many of you folks went into student debt. That's one great thing about City College. Nobody goes into debt to go to City College. Anyway, but there are a lot of people that went to fancy colleges and are carrying around hundreds of thousands of dollars of student debt. And I think they've been hoping the Democrats would forgive them. And it looks like that is not going to happen, except on a small scale. Blockchain raised $120 million. One of the companies, let's see, cryptocurrency seems to be becoming mainstream, and maybe we should start taking it seriously. I cover the mathematics of it and how to program it in my cryptography class, but I've regarded it as a terrible investment. But in the last few weeks, it's beginning to be taken seriously by real investors, so it may be a player in the future to a larger extent. And what is this nonsense? Yeah, that's people skipping the line. And I think I'll just, up to the time, I can just mention this is one of the main reasons to take it seriously. Elon Musk put $1.5 billion in Bitcoin. He also bought some Dogecoin, which is one of the minor cryptocurrencies based on Bitcoin, but originally intended just as a joke. And now he's telling people to sell the coin, so the price is going down. So it's that's the problem with it. You're just in a market where just a whale like Elon Musk can just shove the price up and down arbitrarily. It's very strange, and I'm probably old-fashioned, but I would just buy Tesla stock before I'd buy Bitcoin. If you want to have your fortunes controlled by every whim of Elon Musk, you should buy Tesla stock. Buying Bitcoin is just a sort of second-order way to do the same thing. Anyway. All right, so here we are. This is 129S, the Web Application Security class. And here we are. It is the 18th, so we're going to do client-side controls. And I've got a little bit of slides and then quite a bit of demos. And so the main fundamental issue here is that you are doing stuff in your web application and you are controlling something important with script that actually runs in the client's browser, and that is, of course, not good because the clients can, in principle, control that. And so, unfortunately, this is the way web apps typically work. You ask the client to do something like log in, then they send the name and password up to the server, and the server sends back something like a cookie to identify who you are. And then every future request has that cookie, so they know who you are. And then you might have other things like a shopping basket or some other information, and what the server sends that to you, and then you include it in future requests. So your cookies contain more and more information. And what that means is data that the server needs to engage in processing, like go through the stages of making a purchase, often came from the client and not from the server. The server sends data to the client, and the client echoes it back like a cookie. And developers often don't realize that the data they're using and trusting actually came from the client and not from the server. And that leads to this issue of client-side validation. And why would you make something where instead of the server just holding on to the data it needs, it bounces it off the client? And the fundamental reason this happens is because web apps are complicated and involve many servers. So you have a web application that does something, and then you add a new feature, or you connect to a new branch of your company, so you add a new server, And the easiest way to move the data you need over to the new server is to just bounce it off the client. So you click a link to go over and buy something from our new store to add to your shopping basket from the old store. So the developer just makes the new store believe the shopping basket that comes in with the request from stuff supposedly purchased at the old store. And it's too much bother to really make the authentication system move to the new system, so they just believe whatever they hear. That's fundamentally how it happens. You have servers that are not 100% integrated at the server side, and the fastest way to get a new feature out is to just believe data that ultimately came from the client. That's what leads to this, and this is also, I think, what leads to so many Android apps and iOS apps that just store your password locally on the phone, because they didn't bother to figure out how to make a cookie for the phone to store. They just have you log in as if you'd logged in on the web, freshly every time you restart the app, which is a way to quickly add a phone app to your web app, but it is very insecure. So let's take, for example, here, wonder if I can bring this one up directly. Let's find my burp, which is strangely invisible. All right, just a minute. Here's my burp. Okay. So I just went to burp, and I opened the browser, which I may have to. I think I'm just going to quit burp and bring it up again because stuff keeps vanishing off my screens. I have a lot of screens and so many windows, everything gets hidden. So if I launch burp, okay, and next start, okay. Now burp should pop up. Now I've got a nice fresh burp. Okay, so now I go to proxy and turn off intercept and open the browser. All right. And now I can go to here, which is at ad.samsclass.info/hidden.htm, I think. There we are. This is a page that just demonstrates a few of these client-side validations. So there's the page, which is real small and simple, and here's burp, and there's the history, so that should both fit on the screen pretty well. All right. So here, if I buy a phone, quantity is 1, and I submit it, then it says you bought one phone for $449. And if you look at the post request that did that, the post request sent up to the server, quantity equals 1, price equals $449. And then the server responds. I can render for such a simple page. Inside here it says you bought a phone for $449. And of course the problem here is the price came from the client, not from the server. So if I send that to the repeater and I just change the price to like 4 and send that, now it says you bought a phone for 4. So here's the server believing a price that ultimately came from the client. That's probably the simplest case of this client-side validation. And here, for example, is a cookie discount. You can click here to get a discount. And now you can buy one. So if you look at the proxy history, there were 2 requests. Here's the one that set a cookie. So when you click the first request, it went to the server, and now the server set a cookie saying discount equals 10. Which class of vulnerability does it classify in OWASP 10? Trusting untrusted inputs is one. I'm not sure which version it is, but yeah, that's in the OWASP top 10. There's trusting data that came from untrusted inputs, which is the best match for this. So here, I set a cookie from the server, and now when I buy, I send a request where I say buy the thing, and the discount is here. Discount is 10. And here's the post where I buy it. Quantity equals 1, price is $449, and cookie discount equals 10. So the response is you get a discount of 10. And so again, the discount is being sent from the client. So if you go to the repeater, you can, of course, just change it. if I want to make the discount 100 and send that request, then it'll see you bought a phone with a discount of 100. So it's very much the same thing. And these are all pretty much similar. Here's buy an iPhone. This one here, you don't even need burp for. So I buy an iPhone 1 with a price of $449. Now here I can't change the price right there. But if I submit it, you look up in the URL, and right here is quantity equals 1, price equals $449. So I can just change the price right there, like trim off the 9, and now it's 44. So that's the easy case. When you have parameters right in the URL, you don't even need burp. Although you could, of course, do that in burp. And here's a referrer. I'm at samsclass.info. When I try to buy a phone, it says you can't do it because you didn't come from apple.com. But it's determining that you didn't come from apple.com. Now, the right way to do this is you ought to come from a buy page at apple.com, and it ought to have a hidden field, which is a random number. And then when you go to the next page, it should check that hidden field and make sure it's the right random number. That's how I make sure you really came from my page. But in this case, it's just believing the referrer. So if you take that one from the proxy, and that would be probably this one. Let's see, response, yep, failed. Failed to buy a phone from apple.com. So when I send that one to the repeater, up here I can find the referrer, and I can just change that to https apple.com. And if I spell apple correctly, it should work. Now congratulations, you bought a phone from apple.com, because it's believing this referrer, which is under your control. And this is like phone calls that believe the return phone number that comes in with them, or emails that trust the from address. All these are unvalidated quantities that can be spoofed. And here's the length limit. If you buy an iPhone, I try to buy 1 and I get 1, but my goal is to buy 10. But if I try to buy 10, it won't let me type the 0. Now the reason it won't let me type the 0, if I inspect this, I'm going to highlight it, right click, inspect, and let's see if I can make that bigger. Yeah, I can. Good. So you can see here, I was hoping it would go right to that object. Let me try the quantity itself, see if inspect will go there. There we are. So here's the form, and here's the code. And see this parameter, max length equals 1 in the input form, means it will only let you type 1 character. And this is the kind of thing a lot of developers do. They have some kind of HTML or JavaScript that runs in the browser that limits what you can put in. So you'll say there, they can only put in 1 digit, so they can only buy a maximum of 9 phones. But of course, that's not true, because I cannot use your form. I can use burp, for example. And so here's the one that bought 1, and I can send this again to the repeater. And I can just change that to 10. And I didn't use the form, so the length limit did not matter. And that's why this sort of thing should be enforced on the server. The server should look at that number that comes in and make sure it's not over your maximum. You shouldn't trust a client-side control like this to block it. All right. And down here I got script-based validation. So the quantity is limited to 5. So if I put in 6 and submit, it pops up a box saying quantity too large. So if you want to see how that happens, you can just view the page source, and up at the top is validate the form. This is how you'll typically see it. There's a form validation JavaScript that checks and pops up a box if the quantity is too large. And the form there calls this script. So you could just turn off JavaScript. You could just save a copy of the page locally and modify that, or of course, you can just use burp. The same thing being, even though so what I do is I buy a legal amount to get a good request in my burp. Now I bought 5, and now here, when I send that to the repeater and I change this, burp does not run that JavaScript validator the way that form did. So burp has no reason to think there's anything wrong with 6. and I can send that request. And now I succeed in buying 6 phones. So that's more of them. Here's a disabled field. I can buy a phone, and the price is a field, but it's got disabled, so I can't change what's there. So you might think this makes it safe. I can submit it. And now I bought a phone for $449. But again, the same problem is there. That blocked the actual HTML displayed to the viewer from letting me change the number, but it did not change the fact that the quantity was being sent over the network. And so if you send it to the repeater outside a browser, I can change that number. And so I can buy 10 phones. So, and I guess there was an issue here about the price. Oh, the cool thing about this one is, I didn't want to buy 10 phones, I wanted to change the price. Now notice, the price is not obviously in this request, but if you look at the HTML here, let me highlight price and inspect. Okay, and it looks like I have to sort of do it twice to make this work. There we go. And so here, see if I can get this. There we are. There's a thing called price. Name equals price that's disabled. So that tells me the name of the missing field is in fact price. And so I could add that to this request. And price equals 10. And if I got the name right, it is entirely possible that the server will fall for that. And it did fall for it. I bought 10 phones for 10. So I was able to add the parameter that wasn't there because the fact that it appears here as a disabled field suggests that there was at some time a different version of this where that was not disabled. And I can just add that back in. So what would be the mitigation? Yes, Kalsinski, that is the mitigation. Everything should be validated at the server side. Anything that comes from the client, you should take as information, but you shouldn't trust it. Anything important, so when you buy something from a website like this, you should not have the price here. You should just have the product number. Buy product number 3. Then you send that to the server, and then the server looks up the price of product number 3 on the server side. That's the issue. Any important data should be validated on the server side, out of the control of the client. That's the essential lesson of everything we're going to talk about today. All right, so let's go back to the slides. We talked about this. We talked about how to change the price. All right, and by the way, sometimes when you use burp, the response comes back zipped and you can't see it. So if you don't want that, you can just remove this except encoding line, and then you'll get plain text coming back. That works also when you're writing Python scripts. All right, and you can also change that here in match and replace. You can make it automatically replace all request headers with other request headers in burp if you have that problem. Didn't have that problem today. We talked about the discount amount in the cookie and how to modify it, and those we talked about. Then there were hidden parameters. You can have the price here, and all right. Anyway, there's many ways to do it, but in any case, if the data you're needing to use comes from the client, then you can't trust it. And let me see, this is a little, okay. Think of big applications, validating everything from the user would add a lot of performance bottleneck. Is there a better way? There is a better way. The better way to do it is with signed serialized objects. You use something like a serialized Java object, and then you sign it with cryptography, and then when you get it, you verify it. That's the way you do it, so you can trust what came from the client. This is a very important question. That's why you can do it with ASP, and you can do it with Java. You can even do it with Python in this thing called Pickle if you're really old. But there are ways to send a blob of data to the client, which comes back. OAuth does it too. You send them an OAuth cookie, and then that thing comes back. It's digitally signed. So you can verify that it has not been tampered with. That's the way to do it. Good. These are very good questions. All right. So we talked about the referrer header. You can see that. And it is there so you can track where your ads are coming from. If customers are coming from ads you put up, but you can't rely on that data. All right, and we've talked about that. Sometimes the data you see is not obvious. There's something like a pricing token, which is just a random value here. That's another way to do it. Then it would be hard for the user to change that to a different price because they won't be able to find how to change this long number. That's how cookies typically work. Cookies are supposed to be very long so that you can't predict somebody else's cookie. And if that works, as long as there is some, as long as nobody can figure out what the pattern of this is and guess it. That's called opaque data. Now, if you know the plain text, you might be able to figure out how it's done. All right. And you might be able to find other parts of the app that obfuscate it. So if this is in fact an encrypted price value, where it has somehow taken the price of 100 and run it through something like SHA-1 or MD5, then you might be able to deduce that. A better solution, if you want to do this, would be these should just be random numbers, and there should just be a lookup table on the server side. This number means that price, that number means that price. That's the right way to do cookies also. If this really contains encrypted data, then you run the risk that the user will figure out how to decrypt it, or find another part of your app that uses the same encryption function where they can see both the input and the output, so they can get your app to encrypt a different price for them. You can also replay opaque text, right? If this is your pricing token, I could go find a different product with a lower price and get the pricing token for that and try putting the same token here. So that's why, there might be ways for the user to figure out how to defeat this token if you try to get clever and just have some kind of connection between those tokens. This opaque data can be weak. All right, and then you can try to put unexpected data to the server and see if it will default to a different price or something. So I mentioned before, there's this thing called ASP.NET view state. And so you have this thing called the view state, which is a blob of data, and you can add information to the view state. And now the view state will have this item here called view state that just has this long blob of data. Wow. CCSF has vaccines available for 65 and above. That's what's popping up on my screen. Neat. I'm not quite old enough, but that's pretty awesome. They got more vaccines at City College. Anyway, if any of you are 65 and above, you can go to City College and get a vaccine, I guess. Anyway, so the view state will have this blob here, and that includes name-value pairs. So the view state is base 64 encoded when you submit the form. It's sent up to the server as post data. Unfortunately, if you just decode it with base 64, you'll see the price just sitting right there, price $3.99. And Burp contains a parser that will let you modify it. However, the later versions of ASP.NET have the option of using MAC protection, and that's good. Then it has a signature, a 20-byte hash at the end, so that they can verify it. And this is exactly the answer to your question. So here's a parsed view state inside Burp. You can have this parser that shows you what's in there, price $3.99, and some filling stuff. That's what this contains. But if it was a signed view state object, then the user would not be able to change this. The server would detect it by just validating the signature. All right, so here's HTML forms. We talked about that, defeating the length limitation. Sometimes when you refresh a page, you'll just see 304 not modified, and you don't actually get the new page from the server. So server client-side caching is something you have to sometimes defeat. So sometimes you'll see this if modified since, which controls when it would load a new copy of the page. You can force a full reload with shift refresh in the browser. Although I've had a lot of trouble with this, this is why I have a lot of browsers installed. I often have to just go to a different browser to really get a complete refresh of a page. But you can also use Burp to remove these headers to try to get it to just load it without trying to use the cached version, which is what these headers do. These headers tell your browser to not bother reloading this page, just use the cached version if it's inside a certain time period. And then we talked about script-based validation. The post here calls onSubmit return validate form, so when you try to send this number, it goes up here before sending it. And of course, if you modify it after the browser is done with it in Burp, then none of that applies. So if you're going to use JavaScript for input validation, this can be a good thing. For example, if someone's filling out a form and they put the wrong number of digits in a zip code or a phone number, you might as well detect that on the client and tell them there's no point wasting server time and bandwidth sending that bad stuff to the server that will just bounce. So client-side validation has a purpose to help the user fill out the form correctly, but you cannot trust on the server that it has taken effect. So that's the thing to do here. That's the point. Client-side validation can make it faster and have a better experience for the user, so it warns you right away if something is wrong, but it does not mean that the data is sanitized from the server's point of view. All right, and we talked about disabled elements. You can't change them there on the form, but you can add them, and the disabled element is not sent to the server, but you can add it anyway inside burp, like we did. All right, and in burp, there's even a field in options where you can change the response modification. You can like remove JavaScript form validation, so when you reload the page, it will reload the page and take the JavaScript off it. It has the ability to just remove all these features automatically. So that's another fun way to go. All right, and if you do that, the page will load like this, with the hidden field just sitting there and the disabled fields enabled and so on. So that's an easy way to defeat client-side validation. Let me see if I can do that, because things have moved around in the new version of burp, and I don't know if I can find it anymore. Let's see. If I go to Proxy, Options, and Intercept Server Responses, Response Modification. Yeah, here we go. Unhide hidden fields, enable disabled form fields, remove input length limits, remove JavaScript. There we are. If I do that, and then I go back to this page, let's see, how do I get back to the, okay, here, all right. So this page had all those problems. If I turn on all this jazz and just refresh this page through burp, now it modifies. So now the quantity, this one here, I'm buying an iPhone, now I have the price right there. This field is no longer hidden. So now when I buy a phone, I can just change the number right there. There, 10, and submit. Now I get a phone for 10. Now it's just incredibly easy. That one I think I can't change, but this one here, you can just see the page right there. Here's the length limit, but now I can just put in more. It's turned off the length limit. So most of these controls are gone. Here's where the script-based validation is here. So I can only have 5, but not anymore. It's just turned that off. So this is a handy one. Here's the disabled field, but it's not disabled anymore. So I can buy one for a price of 4. So that is a really handy trick. You can remove all the stuff in the reply, and then you get a form that doesn't waste your time with any of that. So that's why people like burp. You know, burp makes all these little tricks very easy and convenient. All right, so I think we're down to the first Kahoot. And let me get to there, which is here. And floating around somewhere. Here's my Kahoots. All right. So this is 5A right here. There. Good. All right. Crow. All right, I guess that's it. All right, so why do web apps send data to the user and expect the user to send it back? All right, that's the point. If you have multiple servers, it coordinates them. Doesn't particularly conserve server resources, but it makes it possible for one server to get all the information it needs from the client without having to have some other channel to get some data from other servers. All right, which item is easy for the end user to modify, even without burp? Yep, that's the URL. You can just see it right there. All right. All right, what do you have to do to make HTTP readable in Burp Repeater? Yeah, this is what I had to do. I think this might have been changed in the latest version of Burp because I didn't have to do that this time. Before, I did have to do this to make the response readable. It came through zipped, so maybe it automatically strips it off now. But anyway, that's an issue if you write your own Python script, I know. You do have to get rid of the accept encoding or you'll get unreadable zipped content. All right, what do you have to do to reload a page? Yep, that's it. Shift refresh. All right. EC will have to tell me who they are if they want their points. Kaizen looks like a real name, maybe. And K, I'm not sure I know who that is either. Oh, okay. K is Kunal, I guess. Is that what you're saying? Kaizen? Oh, Kaizen. Kaizen, okay. You must be Kunal. Good. K is Carla. Good. Okay, good. Good. And Kaizen is Kunal. Okay, good. So I don't know who EC is, although that might be a real initials. All right, good. All right, so let's go back to the slides. And, okay, then there's other kinds of data you deal with, like there used to be Flash, and still sometimes people use Java, and they can process internal data. And even though the code is written in a different language, the end result is the same. It turns into some kind of web request, and you can still modify it on the way out. So here was an example from the textbook. If you have online gambling, a lot of online gambling has been shown to be hackable and rigged and corrupt. So you could perhaps tamper with the game state, you could perform illegal actions, find out what the next card is going to be on the deck, find out what the other player's hands are, and things like that. Anyway, so your Java extensions, Flash and Silverlight are pretty much gone. There's still some Java applets out there, but these things are all going the way of the dodo bird. But there is now HTML5 code to replace them. But anyway, these things compile to bytecode, execute in a virtual machine, and then they often have serialization to transmit data structures, like what we saw with the ASP view state. Java is the one that's still used a lot, especially in enterprise environments. And so the Java runs in a Java virtual machine locally, and it has a Java security policy, which is better than it used to be. It used to be a wide open way to take over your box. And so you can send data as these Java serialized objects. And when you do, it sends a blob like here's a blob of data. And that is Java serialized object is just a blob of binary data. And it can be taken apart on the server with deesser is a burp extension, and it will now show you what it is. It's a map of data like that. And so if you use a serialization unpacker, you can unpack it and see what's in there. And you can try modifying it and see if you can find clues to exploit the server, find things in the responses that give you something like this. For example, when you roll the dice in a gambling app, that might be taking place on the client. You might be able to modify the client-side code to make you win. That's another thing. A developer might not understand that the randomness is actually on the client, not on the server. And of course, you can do it with Android apps too, which we're doing in the Android app class. So I just put this here. What we're doing a lot, it's very much like web apps. You take the Bank of America app down, you unpack it with APK tool, and then you can see all the files and folders here. And so I find one, business credit card details activity, that handles the credit card. And you can then just find the username and password in here for perform login, for example. And you can modify the code to take copies of the username. In this case, I took the credit card number and put it in the log. Then you recompile the app and run it on the phone. And now when you send a credit card number up and a security number up to Bank of America, it puts that data in the log on the phone where it can be stolen by other apps. So this is the same kind of thing you would do, and it's possible in apps that don't employ obfuscation. So you can just read the names of all the methods. It's especially easy in Java, which is what Android apps are written in, and then compiled to Smalley bytecode. This is Smalley, which is compiled Java. Now, when you compile C, a lot of things are missing. You can strip the symbols from it. You no longer see the names of variables and the names of routines, but in Java, you do. This compiled code is still very readable. If you use ProGuard, it's a Java obfuscator, then it tries to hide things by just changing the names to like A, B, and C. But ProGuard, which is the free obfuscator from Google, leaves a lot of it unobfuscated. And so, in fact, this doesn't slow down reverse engineering very much at all in practice. There are expensive commercial Java obfuscators like -O that do a much better job, to where every name will be just like 10 random characters. So now it's very hard to find something like the password or the credit card number. All right. So if you want to handle your client-side data correctly, don't get critical data like prices from the client. If you do, don't trust it. Look up the price on the server. If you do have to receive important data, then it should be signed or encrypted so you can detect tampering. Even if you do that, though, it might be vulnerable to replay attacks. Users might be able to find some other part of the app where they get a blob of data which is correctly signed with a different price in it. and try submitting that. So even in that case, you have to be a little careful. This is why you need to have anti-CSRF tokens. Your page should have a value that's random, which you send to the client in the page, and then you check in the next page to make sure that this client really sent data from that page, that they're not in something like burp repeater sending data. By the way, when you copy things to burp repeater and run them, the fact that it works at all means that's a vulnerable app that doesn't use proper CSRF protection. I should not be able to replay a previous request at all. Every request should have a unique value that can only be used once. And when I replay a request in burp, the app should just refuse to take any of that, because it should only take requests that really came from my page, and that page should have a hidden value that's different every time. That would be much more secure and not very expensive to do. All right, so remember, everything that happens on the client is vulnerable. So anything you do there is just for performance, for the convenience of the user. It is not for security, because you don't know that it really happened. And so you should be aware when client-side validation is there, and you should check on the server to make sure that the client-side validation has really happened. And if somebody had a client-side validation saying, for example, this number should be less than 5, and they send a number that's greater than 5, then you should know that that person is obviously a hacker. They're not really using your app, and you should cancel their session, suspend the account, trigger an alert. You know, this is the fundamental issue we brought up many times. Don't sanitize data and use the data that came from a corrupt entry. You should realize that is a clue that this person is a hacker attacking us, and we should no longer this is not a legitimate customer. We should make a log entry, notify the administrator, freeze their account or something. Don't ignore the clues that somebody is compromising an account. That's valuable information. All right. So I've got another Kahoot. All right. That's apparently it. All right. Which one of these is not compiled to bytecode? All right, HTML is what the browser handles natively. The rest have to be compiled and run by a browser extension that handles that bytecode. Which one did Apple kill? That was Flash. This is what killed Flash. Steve Jobs wanted nothing to do with it. It was everywhere on the web, and Steve Jobs refused to support it on the iPhone. And that killed it commercially. If you can't use it on the iPhone, it's really not worth anything. You can't make a website with Flash if the iPhone users can't see it. And that was really what put cut the head off Flash, and it died after that. Silverlight was Microsoft's imitation Flash, and it never really caught on. All right, how do you make data from the client trustworthy? Exactly the question one of the students had. Yep, that's what the signature does. This is how you make any kind of data trustworthy. You put a cryptographic signature on it, then you mathematically verify the signature, and that means to a very high degree of certainty that you know it has not been modified. All right. All right. CK and K. All right, good. All right, I've got those names recorded. If they're wrong, you'll have to tell me the real name. So I'm going to stop this recording.